Okay, so in this sort of theory video that relates to the tin iodide experiment, one of the key things that you're doing in this experiment is you're doing a titration at the end of the experiment to confirm that the sort of empirical formula of tin iodide is SnI4. And so what I'm going to do is kind of talk and explain about why we perform titrations, what they're useful for doing, and also sort of key tips for making sure that you sort of run titrations accurately. So titrations are a really common analytical method, and what they're used for is determining the molar concentration of something. So for this example, you're using it to basically work out how many moles of iodide do you have in your tin iodide sample, and then from that you can then work out what the empirical formula of tin iodide is. But they all have this sort of general sort of method shown in this diagram. And so what you usually do is you have a conical flask which will contain your kind of your unknown. So in this case, it will be you'll make a solution with your tin iodide sample, and then you'll add an indicator which will sort of give a colour change. Now in this particular titration for the tin iodide, you don't need an indicator because the colour change is actually with the iodine colour change that comes from tin iodide. But in other cases, things like using manganese in terms of like working out other sort of molar concentrations like manganese, for example, then you can use sort of indicators like potassium permanganate, which is a pink in colour. And then what you do is you make up a solution of something that is known, and in this experiment it's going to be how much sort of iodate, that's your potassium iodate is your known sample, and then you fill this up and add this into a burette. And then what you do is you sort of add your known sample to your unknown, you mix it together, you're getting a chemical reaction occurring, and at a particular point where your sort of unknown changes colour, we call this the end point of the reaction. You stop adding your reagent of your known solution, and then you sort of work out how much you've got. And so a couple of key things, hopefully the diagram sort of makes it clear. Okay, you want to make sure you've got plenty of solution in your burette. Okay, it's so you take a difference between the starting reading and the final reading rather than adding all of your solution together. It just means that between the two readings you should be able to get a more accurate amount of how much you've added. And then also whilst you add most of your known solution quite rapidly at the start, once you get to nearer the point where you start to see a colour change, so usually what happens is when you start adding drops and those drops turn the colour that you want to but then start dissipating, okay, you start adding your known solution a lot more slowly until you add one single drop that completely changes it and permanently changes it to the new colour. Okay, and that's your end point, and that's how you make sure you get an accurate end point. So normally what you do in a titration is you would maybe in your first run you would sort of add the solution fairly quickly until you got the colour change to give you an approximate amount of how much solution you need to add from the burette, and then in sort of the second, third, fourth attempts, okay, this is when you add your solution much more carefully nearer to the end point so you can get accurate at reading. And really what you want to make sure you have are sort of two results that are near, if not exactly, the same. And so to make sure that you get two results that are near or exactly the same, it's really important to do titrations precisely and carefully. And so some of the things that you need to make sure that you always do is use the accurate balances that we have in the lab. So these are balances that actually go up to 4 decimal places, so you know how much of your solutions, what the concentrations are, how many moles you have to a high degree of accuracy. Also, when preparing solutions, don't prepare them in beakers or conical flasks. Prepare them into volumetric flasks. These are flasks which have a graduated mark to tell you exactly when you have like 100 mils or 250 mils of your solution as well. And make sure you efficiently mix the solutions together so all your solid is dissolved in there as well, and that will give you an accurate concentration of your solution. And then finally, as well, do make sure you read the meniscus carefully, so you're accurately reading the burette and how much volume you're sort of starting with and finishing with during your titration. And you can see here with the various different eye levels, the correct eye level is you want to be looking at the same eye line as with the bottom of the meniscus. That will give you the correct result. And the meniscus is there. You can see in that curvature, it's at the bottom. That's where you read the value from your burette. Okay, so I think as I mentioned in the briefing video, you're using the Andrews method, and it's a method for determining how much iodide you've got, starting by reacting it with iodate. So you've got your tin iodide solution, okay, so it's going to liberate iodide, and that's going to react with the potassium iodide iodate that you add from the burette. It's going to start by giving you iodine, which changes colour to like a pink violet colour, and then the iodate is going to react again with the iodine, and that's when you start seeing a pink to colourless change again, and that's the end point, is when you see the titration go from pink to colourless. Okay, and so finally, I'm just going to highlight with this titration and all titrations, there's a pretty standard method of how you sort of do your titration calculations to work out how much of the unknown you actually have. Okay, because what you're doing with the titration is you're adding the known. So this is going to be potassium iodate in this example. You're adding it from the burette to your unknown. And so what you know is how much potassium iodate you've weighed out, and therefore you know what the concentration of that iodate solution is. Okay, and from that you can then calculate how many moles of iodate you've used in the titration based on the volume that ends up being added during the titration. Once you've done that, you can then convert the moles of known to the moles of the unknown. Okay, so just going back here, so what we know is that one mole of iodate reacts with 2 moles of iodide. Okay, so your known is going to be iodate. Okay, you can work out the number of moles of iodate you have from the volume that you add in the titration, and from that we can see that 2 equivalents of iodide is formed. So essentially we can then in this particular titration work out that we'll have double the number of moles of iodide. Once we know that, then we can convert the moles of this unknown and work out what the mass of iodide was that reacted with the iodates. And then once we've got that mass of iodide, we can work out, well, if we had this mass of iodide and we weighed out and used this mass of tin iodide, this is the percentage of iodide that makes up tin iodide, and that's how you then work out the percentage mass. There's further guidance of how to do this in your lab script. Okay, so that covers the sort of theory of titrations and also how it's being used and applied for the tin iodide experiment.